Put that order. We group 7 are going to present chapter 7 combination circuit. There are 6 subtopics. 7.1 The series parallel network. It is the combination of two different configurations that is series and parallel. To calculate the voltage, current, and resistance, it is important for us to simplify the circuit. To simplify the circuit, we always start from the resistor that further from the power source. For question 1, R3 and R4 is the furthest resistors. It is series. Then R2 is parallel with S1, mentioned as parallel 1. Then R1 is series with parallel 1 and R5. So the total resistor of this question 1 is 60.
Assalamualaikum, my name is Muhammad Fauzi bin Mansur, student ID TC24055, and I will be presenting about analysis of series parallel circuit. When we encounter a series parallel circuit, we have to simplify the parallel circuit exists in the circuit into a form of a series circuit. How do we simplify it? We could use the formula 1 over R equivalent equal to 1 over R1 plus 1 over R2. For example, as in the presentation slide. Then we could just combine both of these values of resistances throughout the whole circuit.
Assalamualaikum. My name is Danish. We continue from what we left from the previous topic. 7.3 total current. What is total current? Total current is the sum of all the current flowing through different paths in a circuit. It is typically represented as L total and is measured in ampere. Can be calculated using Ohm's law or current divider rule. First, look at this example. It is a combination circuit, parallel and series and parallel. We know there is F3 resistor, and we know that current in parallel, we need to add them so we know the total current in the parallel form. So we must first calculate the current in R3 plus R2. Then we know when we add it together, it will become series with R1. So R1 is the same as R2 plus R3. So we know the total current in this circuit. Okay. 7.4 voltage drops. Voltage drops refer to the reduction in electrical potential voltage that occur as electric current flow through a circuit. This phenomenon is primarily due to resistance of the conductor and component within the circuit. It can be calculated using Ohm's law or current divider rule, KVL or KCL, or combination of each of the law or the formula that we know. So
7.5 circuit with two sources. KCL used for point F. Point F, I1 plus I2 equals to I. Equation 1 form. And then KVL is used for GFGDC, this loop. Then this loop is opposite with the I2. So this minus 2 times I2. 2 is the resistor here. So equation 2 is formed. Same with the equation 3. Then equation 2 times with 5 plus the equation 3. We can get this equation. Then I1 is found. I2 also found by substitute the I1. Then I found by substitute the I1 we find here, and I2 we find. Here have a question. Try to find the voltage drop across the 8 ohm resistor. So we just time the I with power with the 8 ohm. The answer we can get is 4.18 watt.
Next, I will be presenting about Wheatstone bridge. How do you recognize if the circuit consists Wheatstone bridge? Well, a Wheatstone bridge is when, as in the figure next to me, the output between node A and node B is equal to 0. And how do we calculate values of resistances in a circuit with Wheatstone bridge? We have to use the formula V1 over V3 equal to V2 over V4. We could apply the Ohm's law in this situation, whereas V equal to IR, which will be I1 R1 over I3 R3 equal to I2 R2 over I4 R4. Before we conclude, we have a few questions for you. Your thoughts and feedback will help us better understand your perspective and improve our work. That is all from us on behalf of Group 7. Thank you all for your time and attention. We appreciate your support and look forward to your feedback. Thank you.